Okay, this question is going to look at a cumulative frequency graph and a histograms. So the key thing is, the first question is, we've got a school nurse records the height in 8 centimeters of each of 180 children. The information is shown below. So rather than having the individual heights, we've got them grouped together between different class widths or different intervals. The key thing in the first question is calculate the estimate of the mean, give your answer to one decimal place. So the key part of this is the fact that it says estimate. Now, the reason why we can't give an actual value of the mean is because of these intervals. We've got no idea what those values are in each of the intervals. It could be that all 8 values are 60, or it could quite easily be, or 61. It could be all of those values are 70. There's no way of knowing. So whatever we do, we're going to end up with an estimate. So the key thing with this question is we need to come up with some sort of value that we're going to use, and the convention is that we find the midpoint. So I'm going to extend this table down to include a midpoint. Okay, and that's halfway between the bounds of the class width. So halfway between 60 and 70 is 65. Between 70 and 90 is 80. Between 90 and 100 is 95. Between 100 and 110 is 105. Between 110 and 115 is 112.5, and halfway between 115 and 125 is 120. Notice that there's no gaps between each of the groups. So if something was 70, it would be included in this left-hand column. If something was 70.1, it would be included in this right-hand column. Okay, so now that we've got our midpoint, we can do find the total of all the values by taking the midpoint times the frequency. All right, so in this case, it's going to be 65 times the frequency, which is 8, which gives us the answer 520. So what I'm going to do is carry on for each of those values, working out the total. So you do need to be careful about how you manage your answers here, but I will carry on and calculate that. So I'll go 26 times 80, which gives me 2080. I'll go 35 times 95, which will give me 3,325, and then I'll go and fill in all the rest of them. So to get our estimate of them, now that I've found the totals for each of the midpoint times the frequency, to work out the mean is going to be an approximation of the sum of all the midpoints times the frequency divided by the sum of the frequency. So I can work out the sum of the frequencies 180 from up here. So it's going to be 180 on the bottom, and then I'm going to add up all these other values together. So the 520, the 2080, the 3025, and so on and so on. All right. If I do that, I end up with a total of 18,030. Sorry, that shouldn't be an equal sign, it's an approximation, which equals 100.2 centimeters squared to 1 dp. So the important part of this question is it does ask for the answer to be 1 dp. I'm not sure of what the penalty would be if you included 100.167 or something like that. So don't forget to write your answer here as well. All right, moving on to the next part of the question, which is looking at in a histogram showing the information, the height of the bar interval. For the interval 60, h is greater than 60 but less than or equal to 70 is 0.4. Calculate the height of the bar of the following intervals. So the key thing you need to remember about bars and histograms is that they are the class width by the frequency density. Okay, so the actual area is equal to the frequency. So the height is the frequency density. So what that means in our example here, between 60 and 70, we've got a frequency of 8. It means that the area of our bars are equal to 8. Our class width is equal to 10. So our frequency density would be 0.8. So in other words, for us to work out our frequency density, we have to go the frequency divided by the class width. Okay? Now, I suppose the important thing about that, though, is that we're also told that our frequency density of 0.8 has a height of 4 centimeters. So it's in a ratio of 0.4 centimeters. So what that means, if we simplify that ratio, it means 0.2 of frequency density is equal to 0.1 centimeter of height on our graph. So the key thing is we need to work out for our other values here, we need to work out what their frequency density and then work out their height. All right, and the reality is, because it's 2 to 1, we take the frequency density and divide it by 2. So if we take a look at our 15 to 125, so the class width of that is 10. We've got our frequency of 1.6. So I'll use a different color here. So that means that our frequency density for this one would be 16 divided by 10, which is 1.6. So then for the height, we just have to halve that. So it means our height would be 0.8. So which makes sense because the class width of our original one was 10, so they're the same class width, and this is double the frequency. So it makes sense that it would be double the height. Okay, I'll change color. So then looking at, for this one, between 110 and 115, you can see that the class width is 5, the frequency is 28. So the frequency density would be 28 divided by 5, which is equal to 5.6. Meaning that the height would be half of that, which would be 2.8 centimeters. Let's find a different color. So let's use yellow. So for this last one, the class width is 20 and the frequency is 26. So the frequency density is 26 divided by 20. So where is that? Which is 1.3, which means that our height must be 0.65. Okay, so that's the question. I really recommend you spend some time looking at frequency density. We don't really use it in the New Zealand curriculum, so it's something you won't be familiar with, and it's likely to be a question in the exam. So moving on to C. This is a question about cumulative frequency. And what we have to remember about cumulative frequency is that it's like a running total of frequency. So to start off with, everything that's less than 70 would just be 8. So we can write 8 in there. Now, for less than 90, it would be everything. It would be 8 plus 26, which in this case would be 34. So everything less than 100, we'd have to add another 35, which would give us 69. For everything less than 100 and equal to 110, we have to add another 67, which would give us 136. And for everything less than 115, we'd have to add another 28, which gives us 164. And then for everything less than 125 centimeters would be 180, which makes sense because that's our total. So that's relatively simple. Where it gets slightly more complicated is then trying to replicate that in the graph on our right hand side here. So I'll just move that up. So you can see on the screenshot that was taken, the top part of the question has been taken off. So we're missing all the way up to 180. It shouldn't affect our graph, but we just have to remember that we have to add on the flat line at the top. So you can see the heights there. So what we need to do is plot our points. So again, we can get our trusty ruler out, start at 70. And then what we want to do is mark off 8. So again, try and work out what the points are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, meaning that every square is 2. So we're going to find 1, 2, 3, 4 there. So that's 8. Okay, then we're going to move on to 90. And we're going to put 34. So that means it's going to be 3 from the top. So across there, 3 to the top. 1, 2, 3. So we need to put a point there. And you can go along and mark your points. So 69 for everything below 100. So if that's 60, so we want to go up 1, 2, 3, 4, 5. So slightly less than that. Again, try and make sure the point's between those two values. So you can see now I've included all the points. Really hard to do the top one up here because obviously the scale was cut off, but that needs to be as accurate as possible, making sure that we've tried to get that. So then what we need to do is make sure we start with frequency at 0 because there is nothing that is below 60 from our scale. So not a point, but just keep that as a line. Actually, I'll do that properly and get rid of it. And then we need to make sure we try and do a smooth curve that goes through all of our points. Obviously, this is going to be an estimate because it's done by hand, but what we can control is making sure that our line goes through all the points. The other thing that they can be picky about is making sure that our line flattens off when it hits the maximum. So we need to make sure that's dead flat along that 180 line if we have it. So key points for the graph goes through all the points that you've drawn. It starts at 0, 0, and we have a flat line at the top. So then as far as finding the interquartile range and the 70th percentile and things like that, so the interquartile range is between the lower quartile and the upper quartile. So we need to find the difference between 180 divided by 4 or times 0.25 and 180 times 3/4. The 70th percentile would be 180 times 0.7.